Have you ever noticed the humming noise while passing by a substation or high and extra high voltage transmission line? Have you ever noticed the violet glow that occurs on high or extra high voltage transmission line? What is all of this? Well, in electrical engineering, this is called corona effect or corona discharge. Hello everybody, I am Yasin. Through this video, we will learn corona effect. Through this video, what we will learn? Number 1. What is corona effect? What are the effects of corona and how it is produced? How can we minimize it? At first, we will learn what is corona effect. We have two conducting electrodes parallel with each other, separated in air by distance d. We can see in this slide. The distance between two these conductors are air. This is the real thing we can see. As we know, air is not perfect insulator, or in a simple language, air is not perfect dielectric. In normal condition, there are lot of free ion or electrons in air. Let's have these two electrodes are carrying 25 kilovolts. As they are carrying electricity, each conductor will maintain a electric field. We can see in this slide. Each conductor is generating its electric field. So the free ion of electron will acquire some motion from this electric field and they will start to maintain a very small current. This current is negligible almost if the electric field intensity is less than 30 kV per centimeter. 30 kV per centimeter. This 30 kV per centimeter, as I am saying, based on some studies and different of calculation, not my view. So, if the electric field intensity is less than 30 kV per centimeter, then the value of current flowing between two these will be negligible and we can ignore it. But when we will increase the voltage 25 to 45 kV, it is increase the intensity of the electric field. We can see it that let's say it is now 40 kV per centimeter. The air will lose its insulation property and the electrical breakdown occurs. An arc will stuck between two these electrodes. We can see in this slide. Same thing happen when conductors are carrying high or extra high voltage. The only difference is the distance between two these conductors. So when the line are carrying high or extra high voltage, the air surrounding to these electrodes are become ionized. Intensity is maximum at the surface of the conductor. As we move it away from it, it will be decreasing. It is like the magnet and the clip. You can see in this slide. If we take a clip near to the magnet, you will feel more force. If we take the clip from the magnet, the force will be decreasing. We can see in this slide. The same thing happen in the conductor while passing the high or extra high voltage. The intensity is more at the surface and less at the outer surface. So the air near to the surface will become more ionized. So the electric intensity is high enough, and because of the breakdown of air, then the faint violet glow will appear. We can see in this slide, and we can hear the humming noise at the same time. Now we will know about the critical voltage, at which voltage the air is being break down and the corona starts. That is called the critical voltage. This critical voltage depends upon a lot of things. Generally, the critical voltage depends upon some things like the temperature, the humidity, the pollution level in the air, and others like conductor surface. We can see in the slide. Now, here is the thing to remember that the corona effect generally seen in 245 kilovolt or higher voltage line. So while you are passing by a 11 kilovolt or 36 kilovolt, you cannot see the corona effect. So this is how the corona happens. It is time to know what wrong it will do. Power loss over the entire length of line. Interference with television or radio set near to it. As we know, the corona produce a lot of humming noise that is very high frequency, and when this will happen, the high frequency will interact with the TV or radio set near to it. We can see in this slide. Then we can see the noise in our television or the radio set. Now the next is ozone gas production. Yes, corona also produces the ozone gas, which also reduce the life of conductor or insulator. Now we will learn how can we minimize it. Ignoring corona is a good idea at all. So what to do? We cannot avoid corona 100%, so we have to minimize it. Instead, by increasing the diameter of conductor, we can minimize the corona effect. By bundling the conductor in sets of 2, 3 or 4 per phase. By using the corona ring. By using corona ring, we can reduce the corona effect. So let's have a look the summary of this lecture. What is corona? It is an effect in which, due to insulation air are around the conductor of violet glow and humming noise which the ozone gas produces. Generally seen in high transmission line and equipment of 245 kilovolt and above. Effects of corona. Generally, it is loss of power, production of high frequency noise that interacts with near television or radio, production of ozone gas. And how to minimize? By increasing the diameter of conductor, by bundling the conductor, by using the corona ring. You can take a screenshot and you can share this video with someone who need to know about corona effect. Now this is the whole thing I told in my lecture was about the corona effect.